the last law I want to go over, and remember all these laws are applicable if they were fractions as well. If, for example, I have x to the power of a half multiplied by x to the power of, let's make it 3 over 2, which is 1 1/2. The base is exactly the same, so I'm just going to say x to the power of a half plus 1 1/2, which is 3 over 2, and that's going to give me x to the power of a half plus 3 over 2 is going to give me 4 over 2, which is really x to the power of 2. The other law I want to briefly look at, I'm going to write it down here. It says the following: if I have x to the power of m, let's choose some easier bases. Let's make it a to the m, b to the n, raised to the power of p. The simple thing here is, all I need to do is I can just say that is going to be a to the power of m times p multiplied by b to the n times p. And let's see how we can prove that. Well, let's write out that law. And let's choose values, arbitrary values. Let's make m equal 2, let's make n equals 3, and let's make p equals 4. And I'm going to write that out. That's going to be a to the power of 2, b to the power of 3, and that entire thing raised to the power of p. And let's do it the long way. That's going to simply be, remember what p is. P is going to be 4, right? So I want to take that entire bracket and I want to multiply it. This is again the base, and I want to take the base and multiply it 4 times. So I'm going to say it's a squared times b cubed multiplied by a squared times b cubed multiplied by a squared b cubed multiplied by a squared b cubed. Now in this particular case, you've got 1, 2, 3, 4. Let's rearrange that. That is really going to be a squared times by a squared times by a squared times by a squared. 1, 2, 3, 4 multiplied by b cubed multiplied by b cubed multiplied by b cubed and multiplied by b cubed. And if I look at this, well, that's very, very simple. I can just say, using the exponent laws, where if I have the same base and I'm multiplying things, all I need to do is add the exponents. It's going to be 2 plus 2 plus 2 plus 2, which is going to be 2 multiplied by 4. Because 2 plus 2 plus 2 plus 2 is 2 times 4. Multiplied by b to the power of 3 plus 3 plus 3 plus 3, which is really 3 times 4, which is equal to a to the power of, that's going to be a to the power of 8 multiplied by b to the power of 12. So take a moment, review this, rewind the video a little bit if you need to. The shortcut here is, remember you had a rule that said a to the power of m raised to the n is equal to a to the m times n. For example, a squared raised to the 3 is equal to a to the 2 times 3 is equal to a to the 6. And the only thing you really want to do here is you want to say, well, if I have this thing like this, where I've got two variables or two different bases raised to different powers, I just want to apply this rule next to each other for each of them. So again, a squared b cubed raised to the 4 follows the rule where we say a to the n, or make it a to the m, b to the n raised to the p. That's going to be a to the m times p, which can be written as mp, b to the n multiplied by p, which is np. And again, this is going to be a to the 2 times 4 multiplied by, using dot notation here, 3 times 4. Okay, simply put, it's a to the 8 multiplied by b to the 12. Please be very, very careful about whether we are multiplying or whether we think we are adding over here. Remember, you only add if you have the same bases. And so that's more or less the last example I want to look at, and then we're going to do a mix exercise in the next video.